Hello everyone, welcome to Easy Maths. In this tutorial we are going to learn about differentiation. So most of the people raise this question that why is it important to learn about differentiation? Let me start with a story. During Sir Isaac Newton's days, one of the biggest problems was the poor navigation at sea. Because of that, shipwrecks occurred as the ships were not where the captains thought they should be. There was not enough understanding of how the Earth, stars and planets moved with respect to each other. So once the calculus was developed, navigation was better understood by scientists and captains of the ships. Also, calculus can help us to solve many types of real-world problems, such as to find the rates of change and problems related to distance, velocity and acceleration. Acceleration is the derivative of velocity, which in turn is the derivative of the displacement. We use the derivative to determine the maximum and minimum values of particular functions. For example, cost, strength, amount of materials used in a building, profit and loss can be found using the derivative of functions. Derivatives are also met in many engineering and science problems, especially when modeling the behavior of moving objects. So we are going to learn about tangent and normal, gradient of a curve and gradient of a function. Tangents and normals. If A and B are 2 points on a curve, that can be any curve, then the line joining A and B is called a chord. The line touching the curve at A is called the tangent to the curve at A. And the line which is perpendicular to the tangent at A is called the normal to the curve at A. So if you look at this diagram, the line AB is the chord of the curve. And the line which goes through A, which is over here, is called the tangent. And the line which is perpendicular to the tangent is called as the normal. Gradient of a curve. The gradient of a curve, which is a measure of its slope, changes continually as one moves along it. Suppose when moving along the curve in the diagram, so in the sense B tends to A, that at the point A, the gradient stops changing and remains constant. One would then move along the straight line AT, that is along the tangent at curve. So if you look at this diagram over here, AB is the chord and AT is the tangent. We can find the gradient of a curve by the rate of increase of y with respect to x. So we can take any 2 points on the curve and find the gradient. So if we consider 2 points like A and B moves towards A. So when the B moves towards the A, the B changes its position. So once it reaches A, the B becomes A. So the gradient of the curve at the point A is the same as the gradient of the tangent at A. So we can say the gradient of a curve at any point is defined as the gradient of the tangent to the curve at that point and measures the rate of increase of y with respect to x. An approximate value for the gradient of a curve at a point can be found by plotting the curve, drawing the tangent by I and measuring its gradient. This method has to be used for a curve when the coordinates of a finite number of points are known, but its equation is not. When the equation of a curve is known, an accurate method of determining gradients is necessary so that we can further our analysis of curves and functions. So there are two diagrams given and we are going to discuss how the gradient of a chord AB equals to gradient of a tangent AT. So consider first the problem of finding the gradient of a curve at a point A. If B is another point on the curve which is not too far from A, then evaluating the gradient of the chord AB gives us an approximate value for the gradient of the tangent at A. So the closer B is to A, the better is the approximation. So as B moves along the curve towards the A, we get a better approximation. And once it reaches A, so we can say the gradient of chord AB tends to gradient of tangent AD. Or limit of B tends to A, where gradient of chord AB equals to gradient of tangent AD. So like what we discussed before, when B tends to A, the gradient of the chord AB becomes the gradient of tangent AD. The delta prefix, a variable quantity prefixed by delta x, is a small increase in x. Delta y is a small increase in y, and delta v is a small increase in v. Note that delta is only a prefix. It cannot be treated as a factor. If delta x is the increase in the x coordinate in moving from A to B, then x coordinate of B is 1 at delta x. For all points of the curve, y equals x bracket 2x take away 1. So at A, x equals 1, and by substituting x equals 1 in the equation y equals x bracket 2x take away 1, we can get the coordinates of y at A, which is y equals 1. And as there is an increment of delta x at point B, we get the coordinate of x as 1 at delta x, and by substituting 1 at delta x in the equation y equals x bracket 2x take away 1, we get the coordinate of y, which is 1 at delta x bracket 2 bracket 1 plus delta x take away 1. So by simplifying the expression, we get 1 plus delta x bracket 2 delta x plus 1. So if you look at the graph of y equals x bracket 2x take away 1, so A and B are marked on the graph, and the gradient of the chord AB is what we need to find out. So the gradient of chord AB, which is the increase in y over increase in x, to find the increase in y, we need to take away the y coordinate of A from the y coordinate of B, which is 1 at delta x bracket 2 delta x plus 1 take away 1. And the denominator is what we get as the x coordinate of A taken away from the x coordinate of B. So which is 1 at delta x take away 1. By simplifying the expression, we get 2 delta x whole thing square plus 3 delta x over delta x. And by dividing the top and the bottom expressions by delta x, we can get 2 delta x plus 3. So as B approaches A, the difference between their x coordinates approaches 0. So that is delta x tends to 0. As delta x tends to 0, in the expression 2 delta x plus 3, the 2 delta x gets 0, and the answer for gradient at A would be just 3. So we represent it as gradient at A equals limit of gradient of chord AB, where B tends to A. So when B tends to A, the delta x becomes 0, which means delta x tends to 0. So as a result, the gradient at A becomes 3. Now pause the video and try this question by yourself. How did that go? Example 1a. Using the method described above, find the gradient of the curve y equals 1 over x at the point where x equals 2. So we are going to use the same method like what we have done before. So the solution is delta x be the increase in moving from A 2, 1/2 to a near point B on this curve, so that the coordinates of B are 2 plus delta x, 1 over 2 plus delta x. So here we get the coordinates of B as 2 plus delta x and 1 over 2 plus delta x, because we are substituting 2 plus delta x in the equation y equals 1 over x, and there's an increment of delta x. the gradient of chord AB equals the increase in y over the increase in x. So the increase in y equals 1 over 2 plus delta x take away 1 half over the increase in x, which is delta x. Those two gets cancelled off, so the result would be delta x. So by simplifying, the gradient of chord AB becomes negative delta x over 2 delta x bracket 2 plus delta x. And by dividing the top and the bottom by delta x, the answer becomes negative 1 over 2 bracket 2 plus delta x. By taking off the brackets in the denominator, we get 4 plus 2 delta x as the denominator. Therefore, the gradient at A equals limit of negative 1 over 4 plus 2 delta x, where delta x tends to 0. So the final answer for the gradient at A equals negative 1 over 4. So it's always better to draw a diagram like this to get a clear understanding of what we are going to do in order to find the gradient of a curve. Gradient function. Earlier in this tutorial, we found that the gradient of the curve y equals x bracket 2x take away 1 is 3 at the point on the curve where x equals 1. So we will now derive a function for the gradient at any point on the curve. Then we can find the gradient at a particular point by substitution into this derived function. Instead of taking a fixed point on the curve, we will take A as any point x comma y on the curve. Its y coordinate can then be written as x bracket 2x take away 1, since both coordinates satisfy the equation y equals x bracket 2x take away 1. Let B be another point on the curve such that the increase in the x coordinate in moving from A to B is delta x. Then B is the point x plus delta x comma x plus delta x bracket 2 x plus 2 delta x take away 1. So that is the coordinate of point B. Then, like the method which we have used before, to find the gradient of AB, we write down the increase in y over the increase in x. So x plus delta x bracket 2x plus 2 delta x take away 1, take away x bracket 2x take away 1 over delta x. So by simplifying, we get 2x square plus 4x delta x plus 2 delta x whole thing square, take away delta x, take away x, take away 2x square plus x over delta x. And then by simplifying again, we get 4x delta x take away delta x plus 2 delta x whole thing square over delta x. So by dividing the top and the bottom expressions by delta x, we get the answer for gradient of AB as 4x take away 1 plus 2 delta x. Since the delta x tends to 0 as B tends to A, we can find the gradient at any point A on the curve, which is limit of 4x take away 1 plus 2 delta x, where delta x tends to 0, get the answer 4x take away 1. So the function 4x take away 1 gives the gradient at any point on the curve y equals x bracket 2x take away 1. We can find the gradient of the curve, that is the rate of increase of y with respect to x, at a particular point on y equals x bracket 2x take away 1 by substituting the x coordinate of that point into the function 4x take away 1. Thus, 4x take away 1 is called the gradient function of y equals x bracket 2x take away 1, and the process of deriving it is called differentiation with respect to x. Now 4x take away 1 was derived from the function x bracket 2x take away 1. So 4x take away 1 is called the derivative or derived function of x bracket 2x take away 1. Using d dx as a symbol to denote derivative with respect to x of, we may write d dx of x bracket 2x take away 1 equals to 4x take away 1. Or when y equals x bracket 2x take away 1, dy by dx equals 4x take away 1, where dy by dx means the derivative of y with respect to x and is sometimes called the differential coefficient of y. As an alternative notation, we can use the symbol d for derivative or derived function of, that is, d of x bracket 2x take away 1 equals 4x take away 1, where d is referred to as the differential operator. Now 4x take away 1 represents the rate of increase of y with respect to x. Therefore dy by dx represents also the rate of increase of y with respect to x. Similarly, dv by dt means the derivative of v with respect to t, or the rate of increase of v with respect to t, etc. So dv by dt is used when we deal with the differential equations for velocities. So v represents velocity and t represents the time. So by finding the derivative of v with respect to t, we find the acceleration of the motion. Now take some time and work out this question by yourself. Example 1b. Differentiate y equals x cubed plus 3 with respect to x. So the solution is a be the point x comma x cubed plus 3 and b be the point x plus delta x comma x plus delta x whole thing cubed plus 3 on y equals x cubed plus 3. So we are taking a and b as 2 points on the curve of y equals x cubed plus 3. And as we need to find out a common expression for the gradient of AB, we are taking the point A as x comma x cubed plus 3, and we are substituting x plus delta x in the equation y equals x cubed plus 3 to get the coordinates of B. So the gradient of AB equals the increasing y over the increasing x, which is x plus delta x whole thing cubed plus 3 take away x cubed plus 3 over delta x, which simplifies to 3x square plus 3x delta x plus delta x whole thing square. So the gradient at A equals limit of 3x square plus 3x delta x plus delta x whole thing square, where delta x tends to 0. So as delta x tends to 0, we get an answer as 3x square. So we can say dy by dx, or derivative of y with respect to x, equals 3x squared. So that's it for this tutorial. I hope you enjoyed learning about differentiation. If you have any questions, please put them in the comments below. I'm more than happy to answer them. And also go through the links in the description below, which gives you the direction to some practice questions in differentiation. So for all of that and more, I'll meet you in the next tutorial. Thank you.